As you can see, I've got the Bias2 loaded in the rack here. These two sections are identical to each other. If we just plug one of our indicators into the output, from the center position, the offset's not going to add any voltage. If we turn it up, we get more voltage added, and as we turn it down from the center, we get voltage taken away. If we connect a voltage source, such as the square output of this LFO to the input, and then turn up the attenuator, we can see we get positive output when it's high and negative output when it's low. If we flip the attenuator the other way, we're going to get the opposite of that. So we're going to get positive output when it's low and a negative output when it's high. So in this example, we're taking this stepped LFO and we're copying it with a multiple. And then those two outputs are being sent into the inputs of the Bias2, and I've configured the attenuators to be the same. So the two drone sections on the CPM DS2 are receiving the same pitch. And as you can hear, they're playing in the same octave. But if we adjust one of the offsets, we can change the octave at which one of them plays. So let's change this bottom one and it will change drone 2. So this adds voltage, so it's just adding on to the signal that's being received, lifting the pitch of this up an octave. We've got a lot more range than that, we can go further than that if we want to. This is useful for unipolar sources such as envelopes too, so these only go up and then back to the center. Here I've got the neutron triggering its own envelope with this connection. If we connect that envelope connection directly to the pitch of the oscillator, we won't be able to control how far it moves, and also it'll only go in one direction. Up and then back to the center. But if we route it through one of the attenuators, we can control the range and also the direction it goes. So we can just have it move a little bit, or we can flip it so it goes downwards. And then using the offset we can adjust that resting pitch.